Imagine you could shrink down, not just a little, but all the way down, smaller than a grain of sand, smaller than a speck of dust, until you are so tiny that a single drop of water looks like an ocean above you. Now imagine you are standing in a garden, not on top of it, inside it, under the surface, in the soil. What do you see? Most people, if you ask them this question, would say nothing. Dirt, maybe a rock or two, some old roots, darkness. But they would be completely, absolutely, wonderfully wrong. What is actually happening beneath your feet right now, beneath every garden, every lawn, every patch of earth on this planet, is one of the most breathtaking stories in all of nature. It is a story of invisible cities, microscopic hunters, underground highways, and a network so ancient and so intelligent it makes the internet look like a child's toy. And today we are going to talk about that world. We are going to pull back the curtain on the hidden universe below ground. And then, here is the part that will genuinely surprise you. We are going to show you how one ordinary thing sitting in your kitchen cupboard right now can completely transform that world in just a matter of days. That thing is rice. But before we get to the rice, before we get to the part that will make your jaw drop, we need to understand what is actually going on down there. Because you cannot truly appreciate the solution until you understand the problem. And the problem starts with a question that almost nobody thinks to ask. What is soil really? Most of us were taught that soil is basically ground up rock, minerals, sand, clay, a bit of dead plant material mixed in. We treat it like a container, a pot that holds our plants in place while we pour fertilizer in from above. We think of it like a sponge that soaks up water and nutrients, and our plants do the rest. But that picture is about as accurate as saying that you are basically just a bag of bones and water. Technically true, completely misleading. The real soil, living, healthy, thriving soil, is something else entirely. It is an ecosystem. In fact, it is one of the most complex ecosystems on Earth. Scientists have calculated that in a single handful of healthy garden soil, just one handful you could hold in your palm, there are more living organisms than there are human beings on the entire planet. Read that again. One handful. More living things than 8 billion people. There are bacteria, there are fungi, there are protozoa, which are tiny single-celled creatures that hunt and eat the bacteria. There are nematodes, microscopic worms barely visible to the naked eye, that chase and feed on the protozoa. There are mites, there are springtails, there are beetles and grubs and organisms that do not even have names yet because science has not gotten around to classifying all of them. And then there are the earthworms. Earthworms are the big players, the celebrities of the underground world. And for good reason. An earthworm does something almost magical as it moves through the soil. It eats, it burrows, it leaves behind tunnels that act like tiny airways, letting oxygen and water flow down to plant roots that would otherwise suffocate in compacted, airless dirt. It passes soil through its body, and what comes out the other end, what scientists politely call worm castings, is one of the most nutrient-rich substances in all of agriculture. Worm castings contain nitrogen, phosphorus, potassium, and dozens of trace minerals, all in forms that plant roots can absorb immediately. No processing needed, no waiting. The plant just drinks it in like a warm meal. One researcher described healthy worm casting soil this way. It is like replacing fast food with a home-cooked, nutritionally perfect dinner for your plants every single day. Here is what is even more remarkable. Worms do not create these nutrients from nothing. They are processing the raw ingredients provided by the bacteria and fungi around them. The whole underground system is a food web, a chain of life feeding on life, cycling nutrients, building structure, maintaining balance, and doing it constantly, quietly, without any help from us whatsoever. When that system is working, gardens practically take care of themselves. Plants grow deeper roots. They resist drought better. They fight off disease more effectively. They produce more fruit, more flowers, more food, with less effort from the gardener. This is not magic. This is biology. and it has been working this way for hundreds of millions of years. So here is the question that should be bothering you right now. If this underground ecosystem is so powerful and so effective, why are so many gardens struggling? Why do so many gardeners deal with hard, compacted soil that water just runs off of? Why do plants look pale and weak even after buying expensive fertilizer? Why does the ground feel dead, like you are gardening in concrete with a thin layer of brown dust on top? The answer is heartbreaking, actually, because we broke it. We broke the system, often without even knowing we were doing it. Think about what the modern approach to gardening looks like. We dig and turn the soil over and over, destroying the fragile fungal networks that took years to build. We pour on synthetic chemical fertilizers that give plants a short-term boost but actually starve the microorganisms. Because when nutrients are delivered artificially from outside, the microscopic underground workforce becomes redundant, shrinks, and eventually disappears. We use pesticides and herbicides that do not discriminate. They kill the bad bugs, yes, but they also kill the bacteria, the protozoa, the fungi, the everything. And then we wonder why the soil feels lifeless. Here is a metaphor that might make this click. Imagine a thriving city, millions of people going to work every day, businesses running, goods being produced and traded, the whole system humming along. Now imagine someone decides a city is too messy and complicated, so they bulldoze it, pour concrete over everything, then occasionally drop food from a helicopter. That is what conventional gardening often does to the soil beneath it. The life disappears, the compaction gets worse. The roots cannot penetrate, the water cannot drain, and every year the gardener has to pour more and more fertilizer on top just to get the same results, because there is nothing alive down there anymore to do the work. But here is where the story turns. Because once you understand what soil is really doing, once you understand that it is not a container, but a community, you start to see possibilities that were invisible before. You stop asking, what do I need to add to the soil? And you start asking a completely different question. How do I feed the life that is already there? That shift in thinking changes everything. And this is exactly where our unlikely hero enters the story. Rice. Ordinary, everyday rice. The kind that is probably sitting in your cupboard right now, next to the pasta and the oats. The kind that costs almost nothing and that most of us have eaten hundreds of times in our lives without ever imagining it had any power beyond filling a plate. Rice, it turns out, contains something that the underground ecosystem is absolutely desperate for when it has been starved and damaged. It contains a burst of simple carbohydrates, fast, easily digestible energy that works like a signal flare for sleeping microorganisms. When rice, or even the cloudy water left over from rinsing rice, is introduced to damaged soil, something extraordinary begins to happen. The microbes, which have been lying dormant, waiting for a signal, detect this sudden flood of available energy. They wake up, they start to feed, they multiply with shocking speed, and when the bacteria multiply, the fungi follow. And when the fungi spread their white thread-like networks through the soil, the worms notice. Because worms love to eat fungi and bacteria. The underground banquet begins. Within days, not months, not weeks, the soil starts to change. The microbial activity generates warmth. Tiny pockets of biological heat form just beneath the surface. Worms, which are sensitive to temperature, move toward these warm zones like they are following a map. They congregate. They eat. They reproduce. Within 2 to 3 weeks, those zones of worm activity begin producing castings at a rate that would have seemed impossible just a month earlier. The soil structure starts to shift. Hard, compacted areas begin to loosen. Tiny tunnels form, allowing water and air to move through. The system, the ancient, miraculous underground system, begins to reboot, all from a handful of rice. Now, if you are anything like most people hearing this for the first time, you have one of two reactions. Either you are skeptical, because surely something this simple cannot work, or you are excited, because you recognize that the simplest things in nature often turn out to be the most profound. Both of those reactions are completely reasonable. And in the next part of this story, we are going to go deeper. We are going to look at exactly why rice works. the specific science behind what happens in the soil at each stage. We are going to walk through how to actually apply this method, what to expect to see, and what it means for your garden long term. Because this is not just a gardening tip. This is a window into how life actually works. And once you see it, you cannot unsee it. The world beneath your feet will never look the same again. Let's go back to that handful of soil. Remember it, the one we talked about in part 1, the single handful that contains more living organisms than there are human beings on Earth. We left that handful in a difficult place, compacted, starved, stripped of its community by years of chemical fertilizers, heavy digging, and neglect. It is not dead, not completely. Life is extraordinarily stubborn. Even in the most damaged soil, there are survivors. Bacteria clinging to mineral particles, fungal spores waiting in a kind of suspended animation, a few lonely worms moving slowly through the darkness, finding little to eat. They are waiting. They do not know what they are waiting for. They have no brain, no awareness, no hope in any way we would recognize. But biology has a kind of patience that puts human endurance to shame. Life waits. Life persists. Life, given even the smallest opening, will come roaring back. And that opening, that crack in the door, is what we are about to create. With rice. Let's slow everything down and really look at what happens, step by step, when rice meets damaged soil. Because the sequence of events is not random. It follows a precise biological logic that has been playing out on this planet for longer than our species has existed. It all starts with the starch. Rice is composed of roughly 80% starch. Starch is a carbohydrate, essentially a long chain of sugar molecules linked together. When rice sits dry in your cupboard, those sugar chains are locked up, stable, inert. Nothing is happening. But the moment rice is introduced to moisture, either through water or through contact with damp soil, those chains begin to break apart. The starch starts to dissolve. The sugars become available. And available sugar in the soil is like lighting a fire in a dark room. Soil bacteria are extraordinarily sensitive to chemical signals. They do not have eyes or ears, but they have receptors on their surfaces that can detect the faintest trace of available nutrients in their environment. When those receptors pick up the signal, when they sense that sugar is suddenly available, the bacteria do the only thing they are programmed to do. They eat, and then they divide. One bacterium becomes two, two become four, four becomes 16, 32, 64. In ideal conditions, certain bacteria can double their population every 20 minutes. Think about what that means mathematically. Start with 1,000 bacteria, already an invisible number, and within just a few hours under the right conditions, you can have millions. Within a day, billions. This is the first stage. Scientists call it a microbial bloom, an explosion of bacterial life that happens when a depleted environment suddenly receives an energy source. And it is not gentle or gradual, it is explosive, sudden, almost violent in its speed. The soil, which looked dead from above, is now churning with activity below. But here is where the story gets genuinely fascinating, because the bacteria are not alone. Soil fungi have been waiting too. They are different from bacteria in structure. Instead of being single cells floating independently, fungi grow as networks of incredibly thin threads called hyphae. These threads weave through soil particles like a web, and they are among the most efficient decomposers in nature. A single fungal network can span several feet, connecting distant patches of soil, transferring nutrients between them like an underground postal system. When the bacterial bloom begins, the fungi detect it. Not through any conscious awareness. Again, there is no brain here, no decision-making as we understand it, but through pure chemistry. The byproducts of bacterial activity, the gases and compounds released as they feed and multiply, act as chemical signals that trigger fungal growth. The hyphae begin to extend, to branch, to push through the soil in every direction. And here is the part that will genuinely stop you in your tracks. Those white threads you sometimes see on the underside of old mulch, or spreading through compost, or appearing on the soil surface after rainfall. That white fuzz that some gardeners worry about. That is not mold in the dangerous sense. That is saprophytic fungi doing their most important work. Saprophytic fungi are the great recyclers of the natural world. They specialize in breaking down tough organic materials, woody chips, straw, dead leaves, old roots, and converting them into simpler compounds that bacteria can then process further, and that plant roots can eventually absorb. When rice triggers the bacterial bloom, it simultaneously triggers a fungal explosion, and those fungi start doing something remarkable. They begin to break down organic material in the surrounding soil that has been sitting there, locked up, unavailable, sometimes for years. Old layers of mulch that seem to be going nowhere suddenly start decomposing at visible speed. Woody particles begin to soften and crumble. The tough outer walls of dead plant material crack open, releasing the nutrients stored inside. The soil is waking up, not just the bacteria, everything. Now the third player arrives, and this is the one everyone can actually see, the earthworm. Earthworms are not stupid creatures. They are simple, yes. They do not have complex brains or social structures or anything we would call intelligence. But they are exquisitely tuned to their environment. They navigate through soil by following gradients, moving toward warmth, toward moisture, toward the chemical signatures of food. And right now, the section of soil where rice has been introduced is producing all three signals simultaneously. The microbial activity generates heat. Not a lot, and we are talking fractions of a degree. But in the cool underground world, even that tiny warmth is detectable. Worms move toward it. The decomposing organic material retains moisture better than bare compacted soil. Worms, which breathe through their skin and must stay moist to survive, follow the moisture gradient. And the fungi, the spreading white networks of hyphae, are one of the earthworm's preferred foods. Worms eat bacteria, they eat decomposing organic matter, and they absolutely love fungi. The chemical signature of a fungal bloom is like a dinner bell ringing underground. The worms converge, first one or two, then more. Then more still, drawn in from the surrounding soil by the same signals, following the same gradients, all arriving at what has essentially become the most abundant food source in their immediate world. And when worms gather and feed well, something else happens. They reproduce. Earthworm reproduction is not fast by human standards. They are not bacteria doubling every 20 minutes. But it is faster than most people realize. A healthy, well-fed earthworm can produce a cocoon, a tiny capsule containing multiple eggs, roughly every 7 to 10 days. Each cocoon can contain anywhere from 2 to 20 young worms, and those young worms, once hatched, begin feeding and growing within weeks. This means that in a zone of active microbial and fungal growth, a zone fed by rice, the worm population can increase dramatically within a single month. What started as a handful of sluggish survivors in depleted soil becomes a dense, thriving community. And as that community grows and feeds, it transforms the physical structure of the soil in ways that no tool or additive can replicate. Every worm moving through the soil leaves behind a tunnel. These tunnels, called burrows, are extraordinary pieces of natural engineering. They create channels for air to move down to plant roots that would otherwise be suffocating in oxygen-poor compacted ground. They create pathways for rainwater to penetrate deep into the soil rather than running off the surface. They break up the dense, hard layers of compaction that prevent roots from spreading, and at every moment, the worms are eating and excreting. The castings they leave behind, those dark, fine-grained, slightly glistening deposits you sometimes see on a lawn in the morning, are biochemically unlike anything else in the soil. They are not just nutrient-rich. They have a specific structure, a kind of sponge-like texture, that holds both water and air simultaneously. Plant roots that reach a pocket of worm castings behave like a person who has just found water in a desert. They grow toward it. They branch into it. They thrive. Let's put all of this together in real time, in your garden, with rice. You take a cup of raw rice, you rinse it briefly in 2 cups of clean water, water that has not been treated with chlorine, because chlorine kills the very microbes you are trying to cultivate. You stir and press the rice until the water turns a milky, cloudy white. That cloudiness is starch. That cloudiness is the trigger. You strain out the rice and keep the water. You pour that water directly onto your soil, around the base of plants on struggling garden beds, along the edges of your compost pile. You do it in the cooler part of the day, morning or evening, so the water has time to penetrate before the sun draws it back out. Then you wait. By day 2 or 3, something is already happening below the surface, even if you cannot see it yet. The bacterial count in the soil has already begun to climb. The chemical signals are already spreading outward through the soil moisture. By day 5 or 6, if you carefully lift the surface layer of soil or mulch near where you applied the rice water, you may begin to see the first faint traces of white fungal threads, hair thin, barely visible, but there. By the end of the second week, the worms have noticed. They are moving, congregating, feeding. By the end of the third week, if you push your finger into the soil in the treated area and compare it to an untreated area nearby, the difference is physical and immediate. One feels hard, grainy, resistant. The other feels softer, airier, more alive. If you are lucky, you will pull your finger back and find a worm clinging to it, one of hundreds now living in a space where there were almost none before. By day 30, the transformation is visible from above. The soil color has shifted, darker, richer. The plants rooted in it are standing differently, their leaves a deeper, more saturated green. The mulch on the surface has begun to break down, being processed by the fungal network below. The whole system is running again. This is what living soil does. This is what it has always been capable of. We do not create this. We simply remove the obstacles that have been blocking it and give it a small push with the simplest of ingredients. And maybe that is the real lesson here. Not just about rice or worms or bacteria, but about the relationship between human beings and the natural world. We have spent so long trying to control nature, to override it, to replace it with something more convenient and more immediate. We have filled our gardens with chemicals and machinery and shortcuts, and for a while it seemed to work. The plants grew, the yields came in, but the soil, the living, breathing foundation beneath it all, quietly died. And now, one handful of rice at a time, we can choose to bring it back. The underground city is still there, waiting to be rebuilt. The workers are still there, dormant but alive, ready to return to their posts the moment we give them a reason to. All we have to do is feed them. There is a valley in South Korea where the rice fields have been farmed for over 2,000 years. 2,000 years. Think about that for a moment. In most parts of the world, farmland that gets used intensively for just a few decades starts to show the strain. Soil thinning, yields dropping, the land slowly giving up. But in this valley, generation after generation of farmers have worked the same earth, and the soil today is arguably richer than it was a century ago. How? The farmers there never stopped feeding the life beneath the soil. They worked with fermented plant material, with natural microbial cultures, with organic matter returned to the earth season after season. They did not think of the soil as a surface to grow things on. They thought of it as a living partner, something to be fed, respected, and cultivated just as carefully as the crops above it. They were practicing, without any laboratory or scientific vocabulary to describe it, what modern soil scientists now call biological farming, and what they understood intuitively through thousands of years of observation and tradition. Researchers are only now beginning to fully explain with data and instruments and peer-reviewed studies. The lesson from that valley is not complicated. It is almost embarrassingly simple. Healthy soil grows healthy food. Healthy soil starts with healthy life, and healthy life starts with feeding the invisible. But to truly understand why that lesson matters so urgently right now, not just for gardeners, but for all of us, we need to zoom out, way out, far beyond your garden bed and your rice water and your earthworms. Because what is happening in the soil beneath our feet is not just a gardening story, it is a human story, and it is one of the most important stories happening on Earth right now. Here is a number that should stop you cold. Scientists estimate that the world has lost roughly half of its topsoil in the last 150 years. Half. Gone. The rich, living, productive layer of Earth that took nature thousands of years to build, in some cases, tens of thousands of years, has been stripped away, compacted, chemically depleted, or simply washed into rivers and oceans in the span of a single human lifetime. In some agricultural regions, the topsoil that remains is just a few inches deep. The minimum needed to grow food reliably is considered to be around 6 inches. Many of the world's most heavily farmed areas are already below that threshold, and topsoil, once truly gone, does not come back quickly. Nature builds roughly 1 inch of healthy topsoil every 500 years under natural conditions. We are losing it thousands of times faster than it forms. This is not a distant, abstract crisis. This is the ground beneath the food on your plate. Now, we are not here today to deliver a lecture about global agriculture policy. That is a conversation for another time and place. But understanding the scale of the problem changes the way you see the solution, even the small, personal, garden-sized version of it. When you pour rice water onto a patch of struggling soil and watch the worms return and the fungi spread and the earth darken and loosen, you are not just improving your vegetable bed. You are participating in something much larger. You are practicing, on a small scale, in your own corner of the world, the same principle that needs to happen on a massive scale everywhere. Feed the life in the soil. Let the life rebuild the soil. Trust the system that took billions of years to develop. It works in a Korean valley that has been farmed for 2,000 years. It works in a raised garden bed on a city balcony. It works in a container on a windowsill. The scale changes. The principle does not. But let us bring this back down to earth. Literally, because there is a practical side to all of this that we have not fully explored yet, and it deserves careful attention. One of the most common questions people ask when they first hear about using rice in the garden is this: if it is so simple and so effective, why does not everyone already know about it? It is a fair question, and the answer is actually kind of interesting. The truth is, in many parts of the world, people do already know. Farmers and gardeners across Asia, Africa, and Latin America have been using fermented rice water, rice bran, and rice-based soil treatments for generations. It is embedded in traditional agricultural knowledge that was passed down through families and communities. Knowledge that never got written down in textbooks or published in journals because it did not need to be. It simply worked, and people kept doing it. What happened in the last century is that industrial agriculture, with its emphasis on chemical inputs, standardized processes, and measurable, scalable results, essentially steamrolled over that traditional knowledge. Farmers were told that science had better answers, that nitrogen fertilizer was more reliable than compost, that pesticides were more efficient than natural pest management, that yield per acre in the short term was what mattered most. And for a while, the numbers supported that story. Yields did go up dramatically. The Green Revolution fed hundreds of millions of people who might otherwise have gone hungry. That is real. That is important. We cannot pretend it did not happen. But the long-term cost, paid in dying soil, in shrinking worm populations, in depleted microbial communities, in resistant pests, in chemical runoff, and falling yields that are now starting to reverse the gains of previous decades, that cost is becoming impossible to ignore. And so, quietly, a different kind of revolution has been building. Not dramatic, not loud, happening in backyards and community gardens, in small farms and university research stations. A revolution built on rediscovering what that Korean valley never forgot. Feed the life in the soil. Now let us talk about something even more personal, because this story is not just about soil science or agricultural history. It is about the relationship between human beings and living things, and there is something in that relationship that most of us have lost. Something we do not even realize we are missing until we start to get it back. Think about the last time you put your hands in soil, really in it, not just poking a plant into a pot, but actually working with it, feeling the texture, the temperature, the weight of it. Did you notice anything? There is actually quite a lot of research now suggesting that contact with healthy soil has measurable effects on human mood and well-being. Researchers have identified a specific bacterium, one of the many species that thrives in living, organic, rich soil, that appears to trigger the release of serotonin in the human brain when we are exposed to it through skin contact or inhalation. Serotonin is one of the primary chemicals associated with feelings of happiness and calm. In other words, healthy soil might literally make you feel better. Not metaphorically, chemically, biologically. There is something almost poetic about that. The soil needs us to care for it, and in caring for it, it cares for us in return. Not just by growing our food, but by reaching up through our fingertips and adjusting our brain chemistry. A 2 million-year-old relationship encoded in our biology, reminding us of something we have been trying to forget. We belong to this system. We are not separate from it. So here is where everything we have talked about, the bacteria, the fungi, the worms, the rice, the Korean farmers, the lost topsoil, the serotonin. Here is where it all comes together into something you can actually do. Tomorrow, this week, whenever you are ready, you do not need a large garden. You do not need expensive equipment. You do not need to understand every piece of the science we have been discussing. You just need to understand the direction. The direction is down, into the soil, into the life that is waiting there. Start with rice water if you have never tried it. 1 cup of rice, 2 cups of clean water, stirred and strained. Pour it gently around your plants, your pots, your garden beds. Do it once a week for a month. Watch what happens to the soil surface. Notice when the first worm appears. Pay attention to the color of your plant leaves, whether they deepen and brighten as the microbial population below begins to recover. If you want to go further, try the buried rice method. A small handful of cooked or soaked rice, mixed with a little compost, buried just 2 inches down near the base of a struggling plant. Mark the spot. Come back in a week and gently uncover it. You will see something that most people who try this describe the same way. They say it looks alive, because it is. And if you want to go further still, if this conversation has lit something in you that wants more, start learning about the broader world of biological soil management, about cover crops that feed the soil between growing seasons, about compost teas brewed with specific microbial cultures, about the mycelium networks that can stretch for acres underground, connecting trees and plants in relationships that scientists are only beginning to understand. There is an entire world down there, and we have barely started to explore it. Let us end where we began. Imagine you could shrink down, smaller than a grain of sand, standing inside the soil in the darkness, surrounded by the invisible city. But this time, something is different. This time, the city is alive. The bacteria are moving, feeding, multiplying. The fungal threads are spreading outward in every direction, a luminous white web connecting everything to everything else. The worms are moving through their tunnels, warm and slow and purposeful, eating and building and transforming. The roots of the plant above are pushing downward, following the signals of moisture and warmth and food, reaching deeper than they have reached in years. Everything is connected. Everything is feeding everything else. The system that took billions of years to evolve is running exactly as it was designed to run. And you did that with a cup of rice and a cup of water and the decision to pay attention. That is the real secret beneath your feet. Not any single ingredient or technique or trick, but the understanding that the most powerful force in your garden is not something you buy in a store or pour from a bottle. It is life itself, already there, already waiting. All it needs is you to remember it is there and to feed it. There is a moment that every gardener experiences at least once. You are standing in your garden early in the morning. The light is still soft. The air is cool and smells like wet earth and green things. You are looking at a plant, maybe a tomato, maybe a squash, maybe just a patch of grass. And something about it stops you. It looks wrong, not dramatically wrong, Not dying, not broken, not obviously diseased. Just off. The color is slightly too pale. The leaves are not quite as upright as they should be. There is a subtle drooping, a kind of tiredness in the way the whole plant is holding itself, like a person who has not slept properly in weeks. You water it, you fertilize it, you check for bugs. You move it to a sunnier spot, you try everything you can think of, and the plant just keeps looking at you with that same quiet, exhausted expression. What is it trying to tell you? Here is something that most gardening books never say directly, but that experienced growers understand in their bones. A struggling plant is almost never the problem. It is the symptom. The real problem, almost always in almost every case, is underground, in the soil, in the invisible community of life that the plant depends on for everything. The plant is not sick. The soil is sick, and the plant is just showing you the bill. Today we are going to talk about how to read that bill, how to look at your garden, at your plants, your soil, your whole growing environment, and understand what it is actually telling you. Because once you learn to listen, you will never garden the same way again. And you will never reach for a chemical solution first because you will understand that chemicals are almost never the answer to the real question being asked. Let us start with color. The color of healthy plant leaves is something gardeners talk about all the time, but rarely with enough precision to be truly useful. People say things like, "My tomatoes look a little yellow," or "the leaves seem pale," and then immediately start worrying about specific nutrient deficiencies, nitrogen, iron, magnesium, and reach for a targeted supplement. Sometimes that is the right call, but more often the color story is more complicated and more interesting than a single missing mineral. Here is what color is actually telling you. Deep, rich, saturated green leaves mean that the plant has abundant chlorophyll. Chlorophyll is the molecule that captures light and converts it into energy. To make chlorophyll, plants need nitrogen. To absorb nitrogen from the soil, plant roots need to encounter it in a soluble form, dissolved in water, attached to specific molecules that root cells can take in. Here is the critical part. The main delivery mechanism for nitrogen in healthy soil is not chemistry, it is biology. Bacteria convert atmospheric nitrogen, the nitrogen gas that makes up most of the air around us, into forms that plants can absorb. This process, called nitrogen fixation, happens constantly in living soil, performed by specific families of bacteria that live both freely in the soil and in partnerships with plant roots. Fungi extend the reach of plant root systems, connecting them to pockets of nutrients far beyond where the roots could travel on their own. Worm castings deliver nitrogen in one of the most immediately available forms in nature. When the soil biology is healthy and thriving, the plant is swimming in available nitrogen. The leaves are dark and lush and strong. When the soil biology collapses, when the bacteria die off, when the fungal networks shrink, when the worm population crashes, the nitrogen pipeline shuts down. The plant starts pulling nitrogen from its own older leaves to feed its newest growth. The older leaves turn yellow from the tips inward. The whole plant gradually pales. You look at it and think, nitrogen deficiency. And you are right, but the deficiency is not in the soil. The soil may have plenty of nitrogen locked up in organic particles. The deficiency is in the delivery system. The biology that should be converting and transporting that nitrogen has been compromised. Pouring synthetic nitrogen fertilizer on top is like delivering emergency food to a city by dropping it from an airplane instead of fixing the roads. It works once, maybe twice, but it does not solve the underlying problem. And every time you do it, you make the underlying problem slightly worse, because soluble synthetic nitrogen actually suppresses the bacteria that do nitrogen fixation naturally, since the bacteria essentially go dormant when the nutrient is already available. You are training the system to be dependent on outside input rather than self-sufficient. The rice water approach works differently. It feeds the bacteria directly. It rebuilds the delivery system from the ground up. The color of your leaves, within a few weeks of consistent biological soil treatment, will begin to shift. Not because you added nitrogen, but because you restored the organism that produces and delivers nitrogen naturally. Now let us talk about texture, specifically the texture of your soil surface. Reach down and pick up a small handful of soil from your garden. Roll it between your fingers. What does it feel like? Healthy, biologically active soil has a quality that soil scientists call tilth. It is difficult to describe precisely because it is almost as much a feeling as a measurable property, but most experienced gardeners recognize it immediately. Soil with good tilth crumbles easily. It is neither powdery and dry nor sticky and clumping. It holds together loosely when you squeeze it, but breaks apart with the gentlest pressure. It feels almost spongy, like there is air in it. Like it is full of tiny spaces. Those spaces are real. They are the tunnels and pores and channels created by decades of biological activity, by worm burrows, by fungal hyphae pushing through particles, by the constant movement of billions of microorganisms processing and rearranging the soil structure at a microscopic level. When you feel the texture, that crumbly, spongy, alive quality, you are feeling the physical evidence of a thriving underground ecosystem. You are feeling what thousands of years of biological activity have built. Contrast that with compacted, depleted soil. It feels dense, heavy, either powdery dry or hard as clay. When you squeeze it, it either falls apart into dust or sticks together in a clump that does not want to break. There are no spaces, no air, no lightness. That is what dead soil feels like, and you can feel the difference with your bare hands. The remarkable thing about rebuilding soil texture through biological methods is that the change is physical and permanent in a way that chemical inputs can never achieve. When you pour synthetic fertilizer on compacted soil, the soil stays compacted. The chemistry changes temporarily, but the structure does not. The roots still struggle to push through. The water still drains poorly or not at all. But when you restore the biology, when the worms return and the fungi spread, and the bacterial colonies build up their population again, the structure begins to change from the inside. Literally, the worm tunnels aerate the soil, the fungal threads bind soil particles into aggregates that hold their shape and maintain those all-important air spaces. The bacterial films coat particles in ways that improve both drainage and moisture retention simultaneously. The soil does not just become chemically richer, it becomes physically different. And that physical change, once established, persists and builds on itself season after season. Let us talk about water, because the way your soil handles water tells you almost everything you need to know about its biological health. Watch your garden the next time it rains, or the next time you water it. Pay attention to what happens in the first 30 seconds. In healthy, biologically active soil, water disappears almost immediately. It penetrates the surface and moves downward quickly and evenly. The soil surface might darken slightly, but within minutes it looks almost the same as before. The water is moving down into the profile, being absorbed and held in the spaces between particles, moving toward roots that need it. In compacted, depleted soil, water behaves completely differently. It sits on the surface. It pools. It runs sideways following any slope, carrying fine soil particles with it. Eventually it might soak in, but slowly, unevenly, and when it does, it tends to create anaerobic, oxygen-free, pockets deep in the soil where plant roots cannot survive. You can also watch what happens between waterings. Healthy soil with good biological structure holds moisture for dramatically longer than compacted soil. The aggregates, those clumps built by fungal threads and bacterial activity, act like tiny reservoirs, holding water inside while still allowing air to circulate. A garden with good soil biology might need watering half as often as the same garden with depleted soil, even in identical weather conditions. This matters for a reason beyond just convenience. Every time depleted soil dries out completely between waterings, the bacteria and fungi that were beginning to recover take another hit. Microbial communities are fragile in their early stages of rebuilding. Repeated boom and bust cycles of moisture, soaking wet, bone dry, soaking wet again, are deeply disruptive to the biological recovery process. Rebuilding soil biology and improving soil water retention are not two separate goals. They are the same goal. The biology builds the structure that holds the water. The water supports the biology. Each one enables the other. This is why when you start using rice water on depleted soil, you often notice improved moisture retention within just a few weeks, before the worm population has had time to fully recover, before the fungal network has spread very far. The early bacterial bloom alone begins to change the microscopic structure of the soil surface, improving its ability to absorb and hold water. The system is already beginning to heal itself. Now let us zoom out one final time, because we have spent 4 parts of this story talking about soil and rice and worms and bacteria. And all of that is real and important and true. But there is something underneath all of it, a current running through everything we have discussed. A question that is bigger than gardening, bigger than soil science, bigger than any technique or method or ingredient. The question is this: what kind of relationship do we want to have with the living world? Because here is the thing: the approach to soil that destroys biology, the chemical, extractive, control-based approach, is not just a gardening philosophy. It is a reflection of a broader way of thinking about nature. The idea that the natural world is a resource to be used, that it exists to serve our immediate needs, that when it stops producing what we want, we override it with something synthetic rather than asking why it struggled in the first place. And the biological approach, the one based on feeding the life in the soil, working with natural systems rather than against them, trusting the intelligence that evolution has built into the earth over billions of years. That is also not just a gardening philosophy. It is a different way of being in the world, a way that requires patience, observation, humility, the willingness to listen to what the soil is saying rather than just telling it what to do. Your garden is a choice. Every time you reach for rice water instead of synthetic fertilizer, every time you let worm castings build instead of turning the soil and destroying the fungal networks, every time you add organic matter to feed the biology instead of chemicals to bypass it, you are making a choice about what kind of relationship you want with the living world. And that choice, made by enough people, in enough gardens, across enough years, adds up to something real. It adds up to soil that is richer than it was before, to worm populations that are larger than they were before, to fungal networks that reach further than they did before, to plants that are healthier, more resilient, more nourishing than anything grown in dead soil fed by chemicals could ever be. It adds up to a different world, built one handful of rice at a time. You already know how to begin. The water is cloudy in your bowl. The soil is waiting outside. Go.